1, lesson 28, solving equations with variables on both sides. This shouldn't be anything terribly hard. Our basic principle is still this, is that if I'm solving for a variable, I need to get the variable by itself. Now, if I have more than one of the same variable, that means I might have to move one of those variables over with the other of its kind to get them alone, to get them by themselves. So to solve an equation with variables on both sides, we still use inverse operations to bring the variables together. So if I had something like, let's say 3n equals 2n plus 3, right? And I wanted to solve that. I'm going to use inverse operations to get the n's together, right, on the same side of the equal sign. So which one am I going to move? Am I going to move the 3n or the 2n? I'm going to move the 2n, right? Because if I move the 3n over, I'm moving my n's closer to other numbers. I don't want that to happen. So I'm going to move the 2n. How can I move the 2n? What is the inverse operation that would be used? Subtraction, right? And the test is always, well, what is 2n minus 2n? Well, that's 0n, so it cancels out that side. All right, what's 3n minus 2n? 1n, or n, right? So n equals 3. Have I solved the equation? Yes, right? We used inverse operations. Okay, so that's the kind of thing that we'll be working with. Granted, some of the questions will be more complicated than this, probably, but that's what we're talking about. So equations with variables on both sides might also contain symbols of inclusion and like terms, so they can be every bit as complicated as anything else that we've looked at. Okay. The first step is to apply this, the distributive property if we need to. The second step is to add like terms, then apply inverse operations and the properties of equality to solve the equation. Basically what they're saying is this, is that if one side of the equation has things that still need to be done to it, we want to simplify both sides of the equation before we start moving things across. Does that make sense? All right, so simplify one or both sides, and then use inverse operations. Don't start using inverse operations if we haven't simplified yet. Okay? All right, an identity is an equation that is always true. It has infinitely many solutions. If no value of the variable makes an equation true, then the equation has no solution. That happens a lot of the case when, let's say we have, let's try 3n equals 3n plus 3. All right, well, I've got to get those n's together, right? So what am I going to do? Subtract the 3n on the right side, correct? So I'm going to subtract 3n. I'm going to subtract 3n. What's 3n minus 3n? 0, right? So 0 equals 3. Well, does 0 equal 3? No, it doesn't equal 3. So this is no solution. Okay? Does that make sense? Okay. All right, so that is an example of an identity. Okay, and I don't know that there's, I think that's it. So we'll go from here and look at some questions. All right, so question number 1 gives us a little bit more to do than what I've showed you. Do I want to, go ahead and move x's around, or do I need to simplify first? Blayton, what do I need to do first, do you think? No, not yet, right? If we go back a little bit, one of the things I said is that if we can, we need to simplify both, one or both sides of the equation to make sure that it's as simple as can be done, that there's nothing left undone. Is there anything left undone on the left-hand side? Yeah, what could I do to the left-hand side, Blayton? Okay, multiply x by negative 2. Okay, what are you going to get there? Negative 2x. Is that the only thing that you're going to multiply by negative 2? All right, what do we call that step, just out of curiosity? Distributive property, right? Does that ring a bell? All right, negative 6 equals x plus 9. Now, are both sides simplified? Can I do anything more to either individual side at this point? I can't do, I mean, can I simplify negative 2x minus 6? Can I simplify x plus 9? Right? There's no like terms left to be done there, right? Okay. So let's see. Tiffany, what would you do next? Subtract the x from the right side. Okay. I'm going to give you a suggestion now rather than later. Yes, we can do that. We absolutely can do that, and we will still be able to get the right answer. Okay? But I'm going to try to give you a helpful hint that might save you the potential for making mistakes later on. And that is, when possible, I want to move things across that are going to leave me with positive numbers. Okay? So if I subtract x from negative 2x, what's that going to give me over on my left-hand side? Negative what? No. Negative 2 minus 1x. Negative 3x, right? But what happens if I add 2x to x? What do I get there? What's 2 plus 1? I'd get 3x, right? It's the difference between negative 3x and positive 3x. We can do it either way, but you know, just so that you're aware of that, okay? That possibility. So I'm going to go ahead and do what you asked. All right, we're going to subtract x. What do we get? Negative 3x. And what are we going to do next, Christian? We got negative 3x minus 6 equals 9, right? Add 6 on both sides. Very good. So I got negative 3x equals what? 15. All right, what do I need to do now? Divide by a negative, right? And that's the only reason I bring it up, all right? So we get x equals what? Negative 5. And I'm going to show you we would get negative 5 either way. Right, but let's go back in time here and see what would happen if we did things a little bit differently. Okay, let's add 2x to this side. All right, it's going to give me negative 6 equals 3x plus 9. All right, I'm going to subtract 9 from both sides. That's going to give me negative 15 equals 3x. I'm going to divide by 3. I'm going to get x equals negative 5. Okay, do I still get negative 5 either way? Yeah. Okay, but there are times where I'm left with something like negative x equals 4, and then I have to divide by a negative 1 to get a positive x equals maybe a negative number. Okay, in which case sometimes it's nicer to have it so that my variable doesn't have the negative number. Does that make sense? Okay. All right, we got time for one more. You guys real quick pick one out. I think there's a number of them in here. I think there's what, 13 questions. We can do 4. Okay, all right. We want to do 4. This is my suggestion, right? This kind of goes back to something we did the other day. Could I get this so that I didn't have all these fractions? What would I have to do? Multiply by the common denominator. And it would have to be the common denominator of 3, 4, 6, and 2. Something that all of those things go into. They all go into 12. Very good. So let's multiply everything by 12 to get everything into a whole number set. All right, so 12 times, is that the same as 1/3? Y over 3. Start from the left. So that's 12 times 1. What is that? What's 12 divided by 3? So I get what? 4y. Okay? What's 12 times 8? 96. What's 96 divided by 4? 24. So that's 24y, correct? All right, what's 12 times 3? 36. What's 36 divided by 6? So that's just minus 6. right? Equals 12y. And what's 12 times 7?
84.
84 divided by 2?
42.
42. Okay. So that's just my thoughts. I think that makes it a little bit easier. I'm not working with fractions at this point. It takes a little bit of time off the beginning. All right, I do want to make sure that everything that's positive is still positive. This is positive, great, positive, great, negative, great, positive, positive. Okay, from here, let's look at the left-hand side. Anything I need to do to the left-hand side? Mia? And what do I get? All right, so she said combine like terms, so we get 28y minus 6 equals 12y plus 42. And we're kind of going to look a little crazy here. Caden, we got about 3 minutes here. Let's try to finish this up. What would you do next?
Minus 12y.
Good, minus 12y. And that's going to leave me with positive y's, right? Okay, what's 28y minus 12y? 16y minus 6 equals 42. Okay, what's next, Anthony? Add 6 to both sides. Add 6. So we got 16y equals what? 48. 48 divided by 16. Y equals, what do we say, 3? Y equals 3. We got this? Perfect.